All right, so I'm going to go through this decently quickly, but yeah, let's just run through going through problem 2 again. So from the beginning, first thing I'm going to do, I need to create this random sample of 100 salaries from these managers. So I'm going to create this random number column, and this random number column in the first cell, D2, I'm just going to type equals rand and get my random number. And then I'm going to copy that. So Command C, and then go to the select box and select the 2,500 cells below this. So D3 colon D 2,501. Press enter and then do Command or Control V. And now I have 2,500 random numbers. Press escape to get rid of that floating dashed rectangle. And now if I change the state of my spreadsheet, these random numbers keep changing. So to stop that, I'm going to select this whole D column, and I'll do Control or Command C, get my dashed rectangle around it, and then go to the top left in this big paste button and the drop down and select paste values. And now I press escape and then try to change the state of my spreadsheet. You can notice that those values are no longer changing. So now I'm going to sort all of these values based off of these random numbers. I'm going to sort the D column from smallest to biggest, and it's going to shuffle all the rest of the columns in a random order. So I'm going to first select the rows that I want to get shuffled. So that would be A2 colon D 2,501. Select all of those. And then all the way over to the right, I'll navigate to sort and filter, do custom sort, and then the drop down, I'll select the random numbers or the column D column. I'm going to sort these values smallest to largest, or you could do largest to smallest if you prefer. It doesn't really matter. And you can see now it's shuffled all these rows. You can definitely tell that by looking at the A column, and it goes 242, 443, 1548, and so on. So now my random sample of 100 annual salaries is going to be just the top 100. You can choose any 100 from the B column, but the top 100 is the easiest. So I could just type in equals B2, and then I will again Control C, and then select cells E3 colon E101. So selecting the other 99 cells below that, and then do Control or Command V. And you should see that these are the exact same numbers corresponding in the B column and the E column for the top 100. And now I can build the table now that I have the random sample. So the sample mean is going to be the mean of the sample. So average of the E column gives me 52,175.9. The standard deviation, the sample standard deviation, STDEV.S of the same range of my random sample. And the confidence level, we used 0.9. If we had a 95% confidence interval reconstructed, this would be 0.95, or if we had a 99% confidence interval reconstructing, this would be 0.99, but it's a 90% confidence interval. So we're using 0.9. And now the standard error, that is going to be equal to the sample standard deviation divided by the square root of the sample size. So divided by the square root of the sample size, well, the sample size is going to be the count of our sample, which this should give 100. The count E to E should give 100. Square root of 100 is 10. So if I did this right, and we have 100 in our sample, then you could just see that the decimal place has moved over 1. Now, the degrees of freedom, again, I don't think you guys have talked about this, but it should just be the sample size. So count E to E, which is 100, the sample size, but the degrees of freedom is the sample size minus 1. So 99. Now to get the t-value, we can use this t.inv.2t function And then I'm going to do 1 minus the confidence level, or 0.1, and then comma, the degrees of freedom. And so you get 1.66. The margin of error, actually, I'll just show you guys. If I had a different confidence level, like if I was a 95% confidence level, and I press enter here, you see this t value went up, right? Means the 1 minus h4 is now 0.05, and it actually leads to a bigger t value. But this problem, again, was with a 90% confidence interval, so just showing that now this is 1.66. Now the margin of error is the t value times the standard error. So that'll be h7 times the standard error, which is h5. Now the interval lower limit is our point estimate, or our sample mean. So is equal to the 52,000 that I got. It'll be a different number for you, minus the margin of error. And the upper limit is the sample mean plus the margin of error. And then this is our final interval.